So we saw a while ago that concepts like mean, variance, and standard deviation can be can be corrupted very easily by if you have one or a small number of outliers or extreme points. So the immediate question is, are there something equivalent to mean, variance, and standard deviation in IDEA that do not have this problem? So for mean, we have something called median. So let's understand what a median is. And before we go and understand how to compute a median, what median is, let me show you that it has the behavior that we want. So I've written some simple code here where so again, median can be computed very easily because NumPy has the function median. So my first value that I'm printing here is the median of all setosoflars. My second value that I'm printing here is I'm taking all the setosa values, I'm appending a value of 50, which is an extreme outlier, right? Because all my values of setosa's petal lengths lie between 1 and 2, right? All of my data points are here. I'm taking one extreme point, which is 50 here, and I'm adding it to it, and now I'm again computing median, right? We saw a while earlier that when we computed mean, this value without the outlier and with an outlier were significantly different. The third thing that I'm printing here is the median of Virginica's petal lengths, and the fourth one I'm printing is versicolor's petal length. Now let's look at these four values. So if you just go slightly down in my prints, oh, you see these values. The median petal length for setosa is 1.5. The median with outlier, this is with outlier. This is with outlier, but it's exactly same as without the outlier, right? This is the type of behavior that we wanted. And the Virginica and versicolor have 5.55 and 4.35. Now these numbers 1.5, 5.55 and 4.35 are very close to the values of mean that we saw a while ago. So if you look at these numbers of means, so just ignore this. This is with outlier, which is significantly different for the mean without the outlier. But here we had 1.55, 5.55 and 4.35, which is very similar to these numbers. So the median value, we'll see how to compute it quickly, but the median values for all of them tends to look very similar to your mean, which means it's very similar to a mean or central tendency. We talked earlier about mean being a central tendency value, right? But it has the nice property that with one outlier or a small number of outliers, the value you get is very similar to the value you get without the outlier. Now let's go and understand how to compute the median. Now, okay, so let's assume I'm given, let's say 7 numbers, okay, or 7 observations. I'm just picking a simple example here. Let's assume I'm given 1, 1.2, 1.1, 2.1, 1.8. So 5 numbers, 1.6 and 1.2. So let's assume this is my x. Okay, this is my set of observations for a variable x. Okay, this could be your petal lengths, it could be your sepal length, anything, so a physical observation. Now the median of that is computed as follows. First step is I sort these values. Sort them in increasing or decreasing order, any order. I'll just choose increasing order for now, right? So if I sort them, what I get is 1, 1.1, I have 1.2, I again have 1.2, I have 1.6, 1.8 and 2.1, right? So these are the values I have. This is my first number, my second number, third number, fourth number, fifth number, sixth number, and seventh number. So once I've sorted them, pick the middle value. Pick the middle value. That's the second step. So of my 7 values, what is the middle value? I would say that 4th is my middle value because I have 3 numbers to the left of this and 3 numbers to the right of it. And what is the 4th value? And 4 is nothing but, since 7 is an odd number, what I'm doing is I'm doing 7 plus 1 by 2. Since 7 is odd. We'll see what happens if the number of data points is even, right? Here 7 is an odd number. So all I'm doing is if I have n numbers, I'll just do n plus 1 by 2. And that will tell me the index. So these are the indices, right? At first index, I have 0.1. At second index, I have 1.1. Third index, I have 1.2, so on and so forth. So my central value here is 1.2. Now, why is this useful? Now I would declare that my middle value is my median. So my median of x is nothing but 1.2. Very simple concept. Basically, what you do is you sort the numbers and pick the middle value. Now, the immediate question you might have is, what if I have even number of points? Let's do a simple experiment here. So imagine if I have one more point here, which is 1.8. Let's assume, right? Then how will my sorting look like? My sorting will look like this: 1, 1.1, 1.2, 1.2, 1.6, 1.8, again 1.8, and 2.1. This is my first number, my second number, my third number, my fourth number, fifth, sixth, seventh, and eighth. And here 8 is an even number. So my n plus 1 by 2 will not work because 8 plus 1 by 2 is 4.5 and there is no 4.5 here, right? So what we do is a simple hack, right? So we know that the central number is somewhere here between 4 and 5 because there are 4 numbers here and there are 4 numbers here, but there is no 4.5 value, right? So what I do is I take the fourth value and fifth value and compute the simple mean of both of them, right? My fourth value is 1.2, my fifth value is 1.6. So what is the average of both of them? 1.4. So I will declare that my median of all my green points here, my median of x, I'll declare it to be 1.4. So if n is even, basically what you do is you take n by 2 point, the point at n by 2 index and n by 2 plus 1 index, and you take the average of both of them. So n by 2 here is nothing but the fourth point, n by 2 plus 1 is nothing but the fifth point. And you took the simple average of both of these points, which is 1.4. That's how you compute median. Now the immediate question I have is, why is median not getting corrupted by an outlier? Again, let's look at a bunch of numbers, right? So let's assume I have 1, 1.1, 1.2, 1.4, 1.6, 1, 2, 3, 4, 5, 1. I'm just putting them in increasing order to start with, right? So this is already sorted, right? So this is index 1, index 2, index 3, 4, 5, 6, 7. What is the central value here? 4, right? So if my x is just these numbers, my median is 1.4. Now let's create a new data set which is x dash, which is exactly the same numbers, right? I'm just copying the same numbers: 1.4, 1.6, 1.6, let's say 1.8, and let's assume I have a number which is 56. Obviously, this is an outlier number because all these numbers are around between 1 and 2, except this number. This is your outlier, right? Or this is your erroneous point. Now, what we did, the difference between x and x dash is nothing but just this one observation. Now we know that the median of x, right? We know that the median of x is 1.4. My question is, what is the median of x dash, right? Now we have how many indices? 3, 4, 5, 6, 7, 8. So I have to take the fourth and fifth values, these two, and I have to compute the average of both of them. The average of both of them is 1.5. So the median of x dash is 1.5, which is very similar to your mean, right? This is very similar. So what's happening here is, by just adding 1 point, instead of taking the fourth value, you're taking the average between the fourth and fifth value, right? The one nice property about median is, if you have a small number of erroneous points or outliers, it can't corrupt your value of median much. Next question is, what if out of the 7 values, 4 of them are wrong? Let's take the extreme case, right? So let's define a new x. Let's assume I have 1, 1.1, 1.2, 5, 10, 20, and 30. Right? Here, what's happening here is, I again have 1, 2, 3, 4, 5, 6, 7 points. But I have more than half of my points which are corrupted. I have 7 points and I have 4 points, let's assume, that are corrupted. Let's assume all these are corrupted. Okay, all these are good points or clean points. Okay, so if more than 50% of my points are corrupted, what is the mean of x double dash here? Let me call this x double dash. So the median of x double dash, okay, is 5. Is 5, right? Because the central value is 4, and so if more than 50% of your points are corrupted, only then median gets corrupted, right? This is a very interesting observation. So some people could argue that these are the clean points and these are the outlier points. So the way you look at it. So for computation of median, as long as less than 50% of your points are corrupted, your median will still remain sensible and sane, unlike your mean. Okay, so median is the equivalent of mean, and it's very, very simple to compute. All you have to do is simply sort and pick the middle value. Extremely simple.